All right, so we were doing a split between me and Derek, just some custom auto scaling we've done for what I do for work. My name is Mitch Anderson. I'm a senior DevOps engineer at Newbie. We do social media analytics, kind of ingest a whole bunch of type of data through sentiment analysis and classifications, and have a nice dashboard that you can see it all in. Technology we use are Go, Ruby on Rails. Most of this is based around our RabbitMQ infrastructure, which we do a lot of message passaging instead of REST calls. We don't do a lot of REST between our services. Most everything is done through message passing. The apps were all written initially in Heroku, so it's all stateless, just with backend databases and data stores. We're 100% AWS. We've been on Kubernetes for about a little over a year now. Lots of Elasticsearch and stuff too. Our problem came from ingest rates. Social media is very fluctuating. Along with we have a couple of thousand customers that will create monitors that will number in tens of thousands. I think is where we're at. With that, so we're anything like monitoring Trump can create quite the influx. And our goal is to keep as much as
I'll have to edit that out. Sorry.
Keep as much as real time as possible on this ingest, because we have people that are watching our dashboard, and you can see it kind of a bubble stream stuff here thing that if they tweet something that they think should show up in their monitor, they're calling within, if it's not showing up within probably minutes, type of thing. So we try to keep it as close to real time as possible, but keeping costs down. This is kind of one of the Prometheus graphs I have. This was pre-auto scaling, and this was actually probably a lighter day. But we get messages, so they get backed up into the millions. They drop fairly quickly sometimes. These ones must have been pretty small, so other times they take quite a while. That's where we can kind of see some of the different types of things we're parsing in there. So Discus, Google Plus, not that anybody uses that.
That's a good question. I
Yes, no,
really
interrupt.
What does Newbie do then?
So we're ingesting social media, and we apply sentiment analysis. So they're classifying. They use it a lot. Mostly our marketing departments are the ones that are using it, because they can also respond to posts and stuff. So they get negative comment on some product or whatever, right? They can respond to it. They can see what classifies or what kind of things are people talking about. Anyway. So how we were handling it before was a lot of babysitting. We had me and one other developer, mostly, that were kind of sitting there watching the queues, had our laptops open constantly, kind of looking at it. And we would manually slide these things around. We need this many of this because it's getting backed up for this many of that. And it became quite apparent when he went on vacation how much he was actually doing. So, and I didn't want to keep it up, so fix this. I came up with my two solutions that I wanted to do. Neither was, well, the first one wasn't perfect. I wanted to be able to match closer to what our ingest rate was and scale accordingly. But a quick way of doing it was just to watch where that queue size was, query rabbit, get a queue size, and then scale pods to match or to work off those queues accordingly. Really fairly simple. I wrote the core of it kind of in the weekend. And then the flip side of that, right, is we've got to have the host scaler part where we actually scale up the Kubernetes infrastructure underneath it to account for those pods being scaled out. So I created two apps, these couple cadence there. Configuration-wise, it looks just like a YAML file. This could be passed in and do a config map. Haven't done it yet.
They're the best.
Yeah. I'll look at them.
If you read it, especially if you wrote your tools and go,
Yeah, it is.
do a customer research definition.
I'll look at them. So it just kind of looks like this. You can see the Q, which is the rabbit, MQQ, how to connect to rabbit as an environment variable. Q threshold and watermark, so the scale up, scale down there. How many pods it's scaling up by, and what it'll max out at. We also added in, Tyler here added in a piece that would actually look at Prometheus as well for applications these other doing alerts. And we would restart those apps. Most of the time they're kind of like the final stream process. It's when they just load up, all they have to do is pull it off Rabbit and throw it into whether it goes to Elasticsearch or Mongo. They would throw those into those. So it was really quick processes. So just to restart most of the time was usually all they do because they're mostly Ruby apps that crash. After it, up here, this has been what it kind of looks like, which we still get the peaks, but everything stays pretty low overall. And I think we do keep, I think the ingest rate, I heard was about 6 seconds, I think, from when we get it into Elasticsearch, the final destination. So,
Mitch, it looks like your peaks on the scale are a lot lower.
yeah.
Well, you've gone down like a couple orders of magnitude.
Yeah. So right here you're about 10,000 here, whereas I think before we were seeing 8 million, 4 million on that one. So. This is a speculator. This is it doing host scaling. The white line here is me adding and removing EC2 hosts, and green and we're mostly CPU heavy, it's the memory, so the yellow line is our memory request rates, and CPU request rates are in that green. And it's designed to, at the moment, it's set to scale down once we get under 40% utilization, so it kind of keeps it in between that 60 and 80. A part of this, and the reason why it's that low as opposed to letting it go higher, is actually a result of the way Deus itself deploys code. It doesn't do it as nicely as Kubernetes native deploy does. It actually duplicates the deployment file and then scales one down and scales one up. So in order that it kind of duplicates your resource allocation when it does that deploy, which is why I try to keep it down around in that 50% range, because that's what we can use it. And it was causing problems otherwise. And then the bottom one here is the kind of the scale pods. For one of the major apps that we do, it's the most resource intensive one. As you can see by the graph saying it creates, we were up over 250 pods with it today. Then some thoughts on what I was doing after that was some scaling. So we have still some of our sentiment analysis actually runs still on straight EC2 instances instead of the inside Kubernetes. It was mostly just because they require about a 12 gig of file system space for a sentiment file. So at the moment, we're just doing those on EC2 instances. We're scaling those separately. But soon I'll add this into, and I actually have this installing that. We are moving off of Deus, so we'll go straight into Kubernetes, and I'll just modify this to scale that way. And as we move away from Rabbit and Q, we're playing around more with Kafka. So we will look at that, and preemptive scaling will be more easily accomplished. But that will, just because the scale up time for some of these processes take about 30 seconds to a minute to come up, to get to load their data sets and stuff. So if I can know how fast things are coming in, I can scale them up pretty before they are required. And that's kind of the bulk of it. I can show you anything you want in it. The code itself wasn't terribly difficult, but
So are both these individual services running inside the cluster or outside?
they're in cluster. What happens that very nice It just goes in term, they're part of an AutoScaling group, and I just go in depth like that.
But there's pod scheduled on that host, right?
You just
kill it.
Like I said, we
You just
are,
kill it.
yeah, we are stateless, so it's,
Are you using spot instances for that?
not yet. I was interested to look at it. We were trying to get, I knew this piece all working, and then we'll start probably trying to look at that.
Are the tools open source?
The code, I could open source if you want.
So let me make sure I understand. So in the traditional sense, I think of HPA, right, for the pod scaling, or cluster autoscaler that is out there. There's actually another one that's coming out that's a little bit interesting as well. Have you been able to do kind of a compare contrast? What you found? Is it more granularity in what you're trying to do? That you find, or are you trying to get a custom metrics scaling as well?
Like I said, I wrote this over the weekend, and mostly it was because I was getting pressure that, they wanted it. I was going to get a Ruby on Rails thing thrown at me and said, here's your thing. And I'm like, no.
At least it wasn't Java.
So I said,
You're gonna have to edit that one.
I do not feel much for Ruby.
No horizontal autoscaler will support like reading your rabbit queue link.
Yeah, and so
That's like a big problem.
Well, kind of custom.
I haven't looked at it, so maybe that would be the
and
answer.
part of those, I do depend on NAS currently, and I do depend on the external rabbit, right? So there are two things that most of us don't have into
So you can do
account.
it outside as well as in.
Yeah, so like I said, most of my two dependencies are kind of things that aren't native to Kubernetes. So that was kind of, they wouldn't fit my needs. I did look at the one that was, if you help scale the EC2 instances underneath, but it wasn't configurable for that 50% ratio, right? It was wanting it to go more to like 80, 90%. And like, if it's 80 or 90%, I can't scale, I can't do much in the way of, because of the way DAS itself works. So it's kind of forced me to change how it's done.
It's pretty awesome you can do something like that in roughly a weekend and then.
Yeah, that's pretty cool. So what do you think is the savings? I mean, that's going to be a business. Both of it's not just a business cost savings, but it almost sounds like it's a customer.
It'd be affecting both customer and visualizations, right? Cost savings, I haven't gotten enough data on it, comparing that. But yeah, it should help right there on both fronts, especially if I'm going to spot instances.
When if you're like, oh yeah, kill nodes, no problem, then you should definitely go with the spot instances because there's essentially no downside.
Yeah.
Other than the off chance you run out of, you can't get any instances. But then you got them watching it and scale up and on command.
So I may have to edit this one, but do you find the spot instances on AWS to be of a good quality that you don't have to qualify them before you bring them into the cluster because they may not be the best CPU or memory configuration on the hypervisor?
My understanding is that they are the same. That you make you're requesting them two different ways, but the end result is that you click in on an EC2 instance ID and you get, other than a tag, you get an indistinguishable thing. If you request an R4, you get an R4. And we're moving a bunch into there, so I mean, I'll tell you if we move a bunch in there and it really trashes our performance, but
We have interesting experiences sometimes, not having apples and apples as far as bringing up the same things.
Are you talking noisy neighbors?
that could be.
So I just wanted to know, right?
We haven't got enough deep enough into it to hit that yet. And we frankly probably wouldn't care. We might be the noisy neighbors. And we might be your problem. Like, when we get in there.
It's wonderful.
The noise neighbor in his other department.
It's his Elasticsearch cluster. He invited the in-laws to live in his cluster.
Thank you very much.
typos, anything embarrassing?
The presentation looks good. I mean,
Carson, with Glide, it built the first time. I guess I should stop whining.
Glide is amazing.
So I was hoping to come into this triumphant, like Mitch. And I was going to show you all these amazing things that how it's working in production. But I did not get this completed in a weekend. So we'll get into it. I went the custom metrics route to your question, Paul. You know, why not use it this way? The answer is what Mitch did is way easier. But anyway, we'll get into it. So real quick, this is me. That's when I got married and before I got fat. So I use that picture everywhere.
I'll edit that one out too.
Can
I call you Cookie?
You certainly can. There are a lot of people, friends I have that don't have a hard time remembering that my name is Derek. So, yeah, I put most of those just to show that I have Derek Perkins everywhere except Twitter, and it really angers me. And I'm with Nozzle. We use Go on backend. We use React, moving from running Docker containers on App Engine to Kubernetes on Azure because they gave us almost $500,000 in free credits. And I'm sure they will have comparable service to GK. Oh yeah, it also does SEO analytics. We help people understand what search engines are doing. So before we were storing Google on Google, now we're storing Bing on Azure. So if we're looking at the different types of auto-scaling, you've got horizontal and vertical across nodes and pods. Vertical node scaling, making your nodes bigger isn't really a thing yet, but horizontal node is just called cluster autoscaler, and we've got horizontal pod and vertical pod, and so just a kind of a quick run through of these different types. The way that the node autoscaling works, when there are unschedulable pods, triggers and creates a new node and then schedules those pods onto the new node. And in reverse, every so often it's checking, okay, do I have excess capacity? And it will slowly scale down and rescheduling things. Depending on what you have set up, if you have some critical pods, or there are ways to kind of screw up with node auto scaling so that it will never scale down. But overall, it should work pretty well, except on AKS, on Azure. They don't do that yet. We have $500,000, so we'll over provision. So then we've got horizontal pod auto scaling, which is triggered to CPU by default. You can also trigger it on custom metrics, which just brings your pods up or down, the number of replicas. There's also vertical auto scaling in alpha right now. And so that kind of has two separate functions. The first is once it's been running for a while, when your pod comes up, it keeps a history. It's not, this isn't the cleanest chart that I grabbed off of Google, but it's storing a history of what has happened. It also requires, they're working on Kubernetes native, having some access to metrics, working on integrating with Prometheus. I have this tiny little link down here that is the vertical pod autoscaler doc. But it keeps track of how much memory and CPU has been used historically. And so it will, when your pod comes in, it will actually overwrite your request and limit based on your history. And then as it continues to run, if it sees that there's CPU starvation or if there are events, it will slowly bring that up. So like I said, it's still in alpha, but it's on the way. And then there's actually a simpler version. I don't know how many of you read this book, A Fish Out of Water, where the goldfish grows to the size of the whatever container it's in. And that's kind of what this add-on resizer is. That's in beta now, I believe, so you can use it on the various hosted clouds. And this is pretty limited, but it allows you to scale a pod vertically based on the number of nodes. So essentially, right, if there's space available and there are X number of nodes, it will multiply your request and or limit by a certain percentage. Or
I think the canonical example of this is DNS, where a small cluster only needs a couple DNS pods of a certain allocation, but if you get lots of nodes, you need more powerful DNS. That was like the driving factor, I think.
cool, that's a great point. So why HPA over the simple solution that we put together in a weekend? As I was getting into this, it is far more difficult than it feels like it should be, but the reasons to do it, obviously it's native Kubernetes. They'll also be testing it in conjunction with all these different node autoscalers, vertical pod autoscaling. You can potentially use them in conjunction. Vertical pod autoscale if you're having out-of-memory events, but for CPU or other limits, you might want to scale horizontally. For us, it's this kind of the same, what we're looking for is the same thing Mitch is. We want to scale based on our queue of work to be done. And also works with other HPAs. And also less future maintenance, hopefully, as things go in and out of the API. So real quickly, this is what a standard HPA definition looks like. You set it up. Typically, it's going to be on a deployment now. And by default, I'm showing a resource here. You have to have Heapster enabled for this to work, and it supports CPU and memory by default. So you set the type to be resource and the target average utilization, and that'll trigger scaling event. The second kind, you can run it on a pod level. So here, if you're measuring your network connections, as soon as you exceed this packets per second, and that's averaged across all your pods, that will trigger a scaling event. Will go up or down. Also, as each of these scale up and down, you can set a cooldown time and a warm-up time to keep your pods from spiking if they take a long time to set up or tear down.
That might actually be the answer to the question, but I was wondering what time and what interval and how long, how many of those intervals are included in that average?
So you can set that separately. Yeah.
Where are the metrics coming from?
Not gonna lie, this specific one I don't actually know.
Okay. We get SeedAdvisor for like a specific thing, but like all of the packets per second.
Yeah, I copied this one out of the example as one of the standard things it supports. Didn't actually look into it. And then finally, you can just set an object. And this could be anything. This is where you're going to be pulling from your own custom metrics. So if you're, say, you want to scale on number of concurrent HTTP requests, you can set that at a service level. This kind, I believe, can be any object in Kubernetes. I've seen it set on ingress and various other things. And so it'll scale as soon as you exceed 100 requests per second. And we'll get into it in a second, how you set up your custom API server to do it, or also how you don't do it. I'll be much better at that. You can also combine these, and so you can have a resource, a pod, and an object all running simultaneously, and it'll run all the calculations and choose whichever scales to the highest number of pods. So again, that's something that for me makes me want more motivated to stick with this longer, much harder approach than doing it. Just when I was chatting with Mitch about it, it's so easy to run a little controller operator and say scale up, scale down. Because you would think, oh, how do I provide a metric like queue length? This really feels like it should be a Lambda function. Here, hit this endpoint whenever you have a question, and I'll tell you the answer. No, that is not how it works. So this is a rough diagram of how this works in the truly Kubernetes, everything decoupled. So you kind of start, you've got your horizontal pod autoscaler that's running. You have this core API server. You also have to deploy, so this is default Kubernetes over here on the left. On the right, you have to deploy a custom metrics API pod that's an API service that'll run. This is where running always on a cloud that set it up for me. I feel like I've been left a little bit short on the Kubernetes the hard way. So I'm not so feel free to jump in if you have a better understanding of when you register a custom API service that's basic for a CRD, where it's running. I believe I don't know if it's master nodes or how it interacts. So
CRDs are
Well,
free.
So, I mean, you can create a custom resource definition whenever free, but when you're bootstrapping a custom API system, I think there's like particular code that you run in the initialization process for the controller. And I know this because I was digging into this back in October, and there's like no documentation.
yeah, it's terrible.
Yeah. So, for the record, this is the understanding I came to.
All right.
So, we're on the same page.
Good. And so you have this API service that you've registered that's running somewhere. And in this example, so just how Mitch was querying RabbitMQ, this is going to query Prometheus for whatever metric. And that will provide it back into the core API server, comes back around through the horizontal pod autoscaler, which then makes a decision on your service, which this green arrow, the service, in most scenarios, it will often be providing the metrics for itself to scale on. So it's a giant inception loop, and there is no documentation. So we will, calling it a demo is very gracious to myself. We will look at some things. These tabs are in multiple windows. It represents my current RAM usage. It's very scattered. So if you come in and you think, oh, I want to just run this Lambda function, they point you at this custom metrics API server in the incubator that is essentially the boilerplate that needs to run. So they want you to vendor the entire repository, including all of the client Go. It sounds terrible. They also want you to glide install as a part of your vendoring process. None of that sounds great. So now we'll jump in real quick. Zoom in.
It's like one of those things that needs like done for it, what they did with controllers, where they have the meta controller that came out at KubeCon recently, where
Yeah.
it does all that dirty work and you kind of farm it off to your other languages and things you're comfortable with.
Right.
Sounds like it needs that.
So, side note, the meta controller was written specifically to be a Vitesse operator, which is sharded MySQL, which we're putting in production now, and it's fantastic. And Clint loves it the most. So they have a lot of different things in here. If you come in here into this command server, this is where you set up a lot of that boilerplate. You can set up options. Sorry, wrong spot. Here we go. I want this sample command server. So this, as far as your start master, this is what your function needs to look like. You're returning a Go Cobra command, not G.I. Joe related. And it takes a lot of the core Kubernetes flags, sets up where your kubeconfig information is, and then it actually runs. And it looks very overwhelming. I compared it. We'll look at the Prometheus version of this in a second, which, starting to compare this, it feels a lot less overwhelming. because this is so much boilerplate. So of this whole function, I'm fairly confident that this right here is the only line that you actually, that's where you implement your quote unquote Lambda function. So it's super simple, obviously, and I got it working easily. But I won't share it with you because I want you to enjoy the pleasure of working on it. So my first thought was that I would just set this on demand, check my queue length, and report it, make your auto-scaling decision. Came into here, decided that I didn't want to do that anymore because I rationalized that, oh, it would actually be great to monitor the history of my queue length. So I'll use this built-in, not built-in, but someone's written this Prometheus adapter to do all that custom metrics work. And again, if we jump in here real quick to this start.go, you'll see that they've copied basically this exact command we were just looking at. And they're running this Prometheus provider here. So they've injected that much in between that client pool and config.complete. So as I continue to get through this, it feels like it won't be as terrible. But one of the other things, so they have a pretty detailed walkthrough here in this Prometheus adapter land. You also have to hope that if you're running in the cloud, that all the proper API server flags have been added. And I honestly don't know how to find out what flags it started with. I did a cluster info dump that dumped 33 megs of data, but I was unable to find any of the flags that have to be running. So
in Azure, is a Kubernetes hosted in Kubernetes? Can you just get all the pods in the kube system and see what their specs are? The way we do it, and again, I don't know, I've not played the Azure Kubernetes, but you can just get pods in kube system, and there are n number of them, however many matches you have, describe them like anything else, or get the YAML and spit out the YAML.
and it shows the flags that were provided.
Yeah, they're just in the command, at least depending on the way you make the YAML, obviously, but at least for me, they're there.
If it's inception, yeah.
Yeah, I'm not sure exactly.
You're
Just do
looking-
it, get all the pods in kube system -o YAML and see if it's fine.
Okay. But I asked, so my workaround, I asked in the AKS GitHub repo, and they said, yes, it should be supported.
That sounds like Azure support. We're editing this, right?
So they have this walkthrough. Another question where I'm not totally sure about as far as what auth and certificates need to be provided to this custom API server. Again, I did Kubernetes the easy way, so I'm stupid about that. Also, I don't care about security because we deal with public data for the most part. Edit that out. No. So there's this walkthrough that I was not able to complete. Then I found this this KubeADM workshop that this is pretty fantastic as far as getting started. I skipped over the KubeADM bare metal stuff because that was hard and not relevant. So, but he walks through in this, he has a lot of these load balancing things set up, and we will run it and watch this not auto scale, but we'll watch how it's supposed to work. But you can follow along with this repo, and in case you are feeling good about yourself, you want to feel humbled, watch his YouTube video. He looks like he's about 14, but I think he's 16. So don't be fooled. He spoke at KubeCon Europe this year and is a Kubernetes maintainer. He did a lot of the ARM and Raspberry Pi work. So I felt really good about myself when he was making this work months ago, and I could not today or previously. So yeah, so right here, he walks through deploying a custom metrics API server and a sample app. So here's my demo cluster. And so this is just a simple node app, because that's what he wrote it in, that when you run it, it just tells you what pod it's running on and how many requests it's served so far. And he also has a metrics endpoint at the end of that he's using to serve up to Prometheus. So if we run this, he's seen about 250,000 requests, and we jump in here real quick, we can run this hey command that's going to hit it 500,000 times at 100. So 250, it's slowly going up. These numbers will jump around because we're randomly hitting the various pods. And so the point is that, right, it's supposed to auto scale based on, concurrent requests that I have set at 1. But if we do a get pods, we're running this sample metrics app. There's just one of them running. We look at the horizontal pod autoscaler. It's unable to find out what that request size is, even though if we scroll up through here and we're pulling, you'll see we're grabbing custom metrics from this endpoint. So Kubernetes actually does know this custom metric that we're registering, but he's thrown an M at the end of this value that makes it unparsable. So I think that's the issue why the auto scaling isn't actually working. But if this were, we would see this magically scale up to 10 pods, and all would be great with the world. But we can see here we've got, almost 1.2 million requests that have been made so far in the service, and that number went down. That makes sense. So we've seen this number go up about 50,000. So anyhow, that's how it was supposed to work and be amazing. But the ideas are all here. Hopefully, I'll be continuing to work on this over the coming week or two. Should figure it out because I believe in myself and I'm older than 16. So, and I'm not currently going to high school. Anyhow, lots of great things. I'm excited about the possibility to scale our workers up as we have work come in. We don't have quite the real-time requirements that some of you do, which is awesome. We kind of we guarantee getting things done within the day for the most part, so we do have some leeway to scale up and down. But I also like the ability to scale all these queues down to 0. So everything we do runs through queue that will be in Vitesse. And so that's how we'll be scaling our workers up and down. So our whole pipeline will be based on queue length scaling. So I have to get this right. And I will. I believe it. So any questions?
What was that repo of the 16-year-old or 14-year-old?
So
Let's hope he doesn't watch this.
Serious editing.
We really need to know.
he's amazing.
Yes, he is. Wonderful.
I'm serious. He just made me feel bad about myself. I'm older and that was good. And I'll put this, I'll make these slides available, but it's, I don't know if you can see that, Luxus, Luxas, QBADN-workshop.
What are the flags that you set on the API server? That seems like that shouldn't be like a requirement.
Let me check in my RAM.
Well,
Yeah,
you
you
can
have to turn on-
CRDs.
you have to turn on the integration.
You could turn, maybe turn on the
What, I can't remember the name of it.
admission controller?
So there's flags on the API server that you have to turn on in order to allow you to register.
Okay, oh, yeah, oh, gotcha, gotcha. So the admission
And it also
controller and
requires-
the
And you also
other,
have to like create a certs, and you also have to sign like the certs for those services with those signing certs as well. There's like a whole crap.
yeah, okay, yeah, that's a whole thing.
It's a long, like, just, I can't remember which of these docs it's in,
Okay,
but it
I'll
says,
think-
before getting started, make sure that all of these things are taken care of.
Right, and if you're just getting a master layer handed to you and you can make it incredibly, even if you run a tool, like half the tools don't tell you where they're putting the options for all these, like, where they're putting the flags that they're
Right.
passing through.
I mean, it's a big doc that, that actually has decent documentation.
Called an aggregation layer.
Yes.
Oh.
And
Pretty good.
just reading through it, the one thing that jumped out at me, if you enable custom metrics without adding like an API server flag, I think it said it disables the like CPU and memory metrics by default,
That's amazing.
but without telling you. It'll just
Was this
switch
on
it out.
production that you did that?
No, I don't run anything in production. We just talk about running.
The music.
Well, that's an incredible business.
Their clients are on dev, right, Derek?
Yeah. And they love it. Any other questions?
That horizontal or the vertical pod autoscaler, do you know what that was based off of work? Because I saw you're pointing at DirectX Man 12 or something.
So that DirectX man, that was just the Prometheus adapter for custom metrics.
Correct. There's another individual who also works fairly hand in hand with that individual, and he wrote something called Resourcerer, spelled like Harry Potter sorcerer, which apparently is an OpenShift tool, but can be used in any Kubernetes. But he did stuff to kind of proactively predict this. I didn't think that it was going to be integrated yet, so it might be disparate work, but he just basically gives you suggestions without making any changes. So you can go then set limitations and then auto scale eventually, but I was
So
wondering when.
vertical pod autoscaler is in the actual autoscale repo in Kubernetes.
Okay.
So I'm
It's in
not
1.8.
familiar with.
It's alpha in 1.8 or is it GA?
Vertica, sorry, I'm reading cluster.
Vertical.
It is under development.
So I was pretty sure that I read this last time, but I'm asking you just to make sure.
Yeah.
When you create a custom metrics controller, you only have one custom metrics controller. So if you have, so this one custom metrics controller has to be able to handle every custom metric you would ever want to create, right?
I don't know the answer to
Right?
that.
Because I think there's like, you're limited to a particular API namespace essentially. API group, sorry.
I'm not
Anyway.
positive on that. The way that the Prometheus adapter works, it makes I believe every Prometheus metric available. And it uses naming conventions. So I think if it ends with total, it treats it as a cumulative metric. If it has no suffix, it treats it as a gauge. But I honestly don't know about if there's a limitation on the number of custom metrics controllers you can run.
I have a question for the whole room. So we talked about, we saw this custom controller, that's pretty neat. We saw the Kubernetes way, which is pretty neat, but hard. Has anybody tried out some of these completely different ways, like the spot inst elastic group, whether that's tetrascaling and you mix spot instances with reserved instances, or Azure's? It's a middleware API that will control your groups and it lets you mix match EC2 sizes and works with Kubernetes. They'll reschedule your pods before it tears down the EC2.
That's funny. I'm working on writing something similar.
Well, it's a port-based service. I mean,
Oh, okay, yeah, I didn't know about it. Yeah,
if yours is open source, I'll like it better.
it will. With the idea, I'm working on something that actually, it doesn't do the scaling part, but it does the resource allocation for you. So it's got custom resource definitions for fleets just groups of nodes that you want. And right now, the two ones we're starting with are AutoScale groups and spot groups. And the idea is that your capacity, a YAML document, send it into the cluster and say, I want this capacity. And I want an AutoScale group of this node makeup and create it, and then you create, update, and delete it through Kubernetes tools, and then it's got a custom controller that does that.
Well,
That's
the sales literature for spotting looks pretty cool. I haven't tried it, so I was hoping somebody else has.
Our
But,
company
or-
did a POC of it, but we didn't really go with it. It was too much complexity for our team.
And then Azure has the virtual kubelet, so you use their container service. And
We're
not even
planning-
do it, host or anything.
So
I was wondering about that.
So we are planning on using it. Right, your price for, CPU and RAM is much higher on those services. We're gonna use them because they all get a unique public IP. Not that we're trying to get past IP blocking, but if you were, that would be a great way to handle it. And so that's how we're planning on getting around that. If you're on Google, they have that built into the GKE. You can set up separate node pools, including, for them, it's preemptible instances, but it's their version of spot instances. They'll scale those different groups for you separately. And another Google thing that they are running in alpha is it's kind of like the vertical pod auto-scaling, but it's node-based. So as you're running, they will start analyzing your usage and help you pick the right node size for your cluster.
There was an open source one called Auto Spottings that we looked at that was similar to Spottings.
Auto spotting. Thanks.
Any other questions?